All right, here we are at 129S. We were supposed to do chapters 1 and 2 last week, but we only did chapter 1, so I'm going to pick up at chapter 2, and we'll probably start a bit on chapter 3 and just see how things go. I got to start the Zoom. I forgot about my remote attendees, which are probably most of them this time. Looking at this room, which is fine. Oh, I better bring out my. Wait, I don't. Oh, that's right. I'm in this room. I don't need Zoom yet. Okay, good. I'm catching on. In this room, the college is streaming it. I only need to turn on Zoom when we do the Cahoots. All right. So, we're down to core defense mechanisms. So, here's what you can do to protect your web app. The last one talked about all these attacks, because every time you take data from the user can put in malicious data, unexpected binary characters and punctuation marks and stuff that confuse the app, and that's fundamentally how you hack web apps. So one thing you can do is limit what the user's allowed to get at. Make them log in before they can get to most of it. That limits the attack surface. You can filter the input to remove stuff that's bad. You can make it difficult for attackers to get in, and you can do administrative monitoring, so you're watching what the app does and noticing when it starts doing crazy things, like when money starts flying out the door, and it triggers a review. So I have one very simple attack, which is, I think, not directly covered by this book, but it is devastating, and it's been very big for the last 3 or 4 years, is to just send an email to the purchasing department at the company and said, please remit the $1 million you owe me, the boss, for that product you bought. And a lot of people have just sent out the $1 million without asking anybody. And then later they ask the boss says, what $1 million? Oh, the boss said you were supposed to pay this bill. And they'll just do something as simple as make like a Yahoo account with the boss's name when the boss doesn't have a Yahoo account. Just make some very simple thing to make it look like they're the boss. And somebody will fall for it. Just send it to a lot of companies. A lot of money has gone that way. And if you had some kind of process that just triggered a review whenever a large amount of money went out the door, that might help, that sort of thing. So users have to authenticate, and then there is session management to keep track of who they are as they progress through the app, which is a very tricky thing, to keep remembering who they are from step to step. And then, of course, access control. If you have kept good track of who they are, then you can limit who's allowed to have access to all the parts of the app as they progress through. The most common and cheapest technique is a username and password. It is the least secure method, but it is the easiest to implement and the cheapest, and so it's most commonly used. It would be a lot better to have two-step with a fingerprint or a PIN that came by SMS or something like that, or client certificates. All those would be a lot better. But the problem is, once your app gets big, unless you're going to pay for a lot of help desk staff, you're going to have to weaken your authentication drastically, because a bunch of people are going to be forgetting their password, losing their phone, and calling your help desk saying, I can't get in my account. And so you're going to have like self-registration for the new people and some kind of account recovery where they can recover their password with just their mother's maiden name or something. And that turns out to be really easy for the bad guys to guess. So there's a fundamental problem there. To save money on the help desk, you weaken the system. And there were no end of exploits. They got into Sheriff Palin's email this way. There was a hack about 1.5 years ago that went around where you could call like Amazon and told them you forgot your password, and they would reveal to you like 2 digits of your social security number. You could call Yahoo and tell them you forgot your password. With those 2 digits, they would tell you like one other fact, and then you could call eBay, and with those 2 facts, you could get another fact. And by calling like 3 or 4 services, you could get enough to fool somebody into totally letting you in Gmail or something. They had a little template of how to do this, because each company would have slightly different questions and slightly different rules about what information they will give you. I know I had friends that called Yahoo and said, I forgot my password. I think it was something like 14 donkey or 14 elephant. And if you get close, they'll read it off the screen and tell it to you, because they can totally see your password in plain text, which is completely insane. There should only be a hashed value that can't be reversed, but Yahoo just had it. The help desk can just see it. That also means you can just slip them 20 and get somebody's password. They can just get in somebody's account. I mean, the help desk can see your password. This is not smart. But I mean, Yahoo was never accused of being smart. The amazing thing about Yahoo is that they just persist year after year while doing everything wrong. They never can finish dying. They finally got into China, though, which nobody else could do. They actually own like 60% of Baidu. Whereas Google can't even get into China. So I mean, America, Yahoo just did one stupid thing after another, but somehow they did the right thing in China, and that's held them up. Anyway, so here's a login function. So you have to log in for security reasons. You only have a limited number of attempts. If you mess up, you're going to have to call the help desk, and we're going to have to send you a security code and all this. Then you have to go through a reactivation process, and you have rules for your username and rules for your password. You know, this is how it goes. There's many things that go wrong. Most usernames are easy to guess. Most people use the same username everywhere. This is how they caught a lot of online criminals, because they were using the name like Flying Frog, and then they found them using Flying Frog at a game site 5 years ago and all these other sites, and you can tie them all to the same person, and you can take them back in time to before the time when they were a criminal, when they were putting their real address on things, and they haven't changed to a new identity. They just keep on using that same name, so you can track them back. Passwords can usually be guessed. People are not that creative. There are plenty of dumps lists of passwords, and there are often logic flaws. Like the one I showed the class yesterday, there was a hotel company in Dubai that would let you type in an email address in the URL, and then you would be able to view anybody's account and modify it based on the URL, because there was a login function, but you could just go past it directly to the view my profile function without passing through to login, and it no longer remembered who you were or cared. And that's quite common. That's one of the many logic defects. So session management is necessary because HTTP is a stateless protocol. It does not keep track of who you are in any particular way. You have to add that in with the developer writing the code. So you have to have some data structure that keeps track of who you are. It's often a cookie with a number that looks like a random number. There's some kind of token that identifies the session, and it could be, it's often a cookie, but it could be something else. So you have some kind of session, and you have to decide how long the session will last. Most companies usually prefer the session to last forever because people have mobile phones, and it is very irritating to log in on the mobile phone. So once they've logged in, they want to not have to log in again, like ever. So typically cookies last for years, essentially forever. High security places like banks actually do kick you out after 10 minutes and make you log in again because they're more worried about these persistent sessions. So one common thing is predictable tokens, where they're not random. They might just be sequential, or they might use a low quality random number generator. If you just use our typical programming language, the random number generator function is in fact not very random at all, quite predictable. And because there's no real source of entropy on a computer, a good random number generator is really not easy to find, and most developers can't be bothered, and they just use the standard one. Another thing you can do very often is you handle the token improperly. I think it was Amazon or eBay about 3 years ago, someone found out that if you post a picture on eBay, the URL has this long number in it. And it turns out that if you go to a password reset and they send you a password reset link, that number is the same. So you can go to somebody's page and read the source code and figure out what the right password reset URL is and reset their password. Because they didn't really separately generate the various random tokens, they reused the same one for different purposes. And as you can see, it'd be very easy to do that, especially in a company with many developers and many versions. Somebody says, well, we need to put some unique string here. Here's a unique string, let's just put that in there. And it'd be very hard to see that coming. So each request has to be approved or denied, and you'll see some kind of denial message when you are kicked out. But often you are able to defeat this. The most common solution is input validation. Now, people usually do this with JavaScript on the client. Rules must contain at least 4 characters, email must be valid and have an add in it, phone number must have only numbers, and so on. Now, the purpose of this stuff is to avoid wasting your server time on invalid input. But if you enforce it with JavaScript in the browser, then it's useless, because you can just turn off JavaScript in your browser or use a proxy like burp and modify it. So if you do put in your code, this must contain only numbers, you cannot assume that the input to the server will be only numbers, because that was under the client's control. And this is probably the most common flaw. Developers usually do not understand what part of their code is running on the client and what part is running on the server. And they write code that seems to work fine, but in fact has important things happening on the client that aren't verified on the server. All right, so you can put in arbitrary text. If you're going to let people have blog posts, they can put in almost anything. Cookies can come up, hidden form fields and parameters and things like the user agent are all feeding data up from the user, and they can all be manipulated. So there are different philosophies. The most common one is to reject known bad, remove apostrophes from things that might have SQL injection and so on. The problem is it's very hard to detect. For example, if you're trying to block SQL injection, most SQL injection has to use select. So you could try to block select, but it might not catch it if you change the case. If you block this, you can try a minor variation that does the same thing. You can do that. Another thing you can do is break it up with other fields, like this select username password from users. You can add extra characters in there, like comments in the middle, that will break it up. things that will make it not match the template of the known bad thing, but it will still be functional at the other end. Another thing you can do is put in null bytes. Null bytes are pretty awesome because they will terminate the string sometimes, and other times they will not terminate the string. So you might be able to terminate the string in the routine that checks for bad characters, but it doesn't terminate the string in the actual logic you're trying to hack into. That happened to SSL certificates about 5 years ago. Moxie Marlinspike and Dan Kaminsky independently presented it at DEF CON and Black Hat. They bought certificates with null bytes in them, so they got a certificate that was star null byte. So it would be accepted by every browser as valid for every domain. So you could sign Google and Yahoo and PayPal and everything with the certificate that you bought. And the certificate company wrote their code in Pascal, so they would cheerfully sell you that certificate because the null byte was not the terminator for that system. So in their system, it was a perfectly valid certificate, star null at mycompany.com. It didn't appear to be a wildcard to the people that sold it to you, but it did appear to be a wildcard to the browsers, to the customers. And that's the fundamental trick of all this stuff. You have multiple components using different technologies, and you find an input which will be misunderstood by one of them and pass the other as apparently okay. So what's safer is whitelisting, where instead of trying to enumerate all the bad things that could come in, instead you enumerate the good things and only let them through. This is the most effective technique when you can do it. But sometimes you can't, because there are things like blog posts and descriptions of pictures and human names that really do contain punctuation marks. Unless you're going to be rude and mangle people's names, which is kind of unprofessional, you really have to let them use it. So this is really crazy. I mean, normally what you do is you check for something bad, and if it's bad, you say input rejected, type it again. But another thing people do frequently, just to keep things moving, is sanitize it. They take the input, remove the bad part, and just keep using the rest of it. This is, of course, really dangerous, but it does make your app appear more usable. It's not always irritating people, making them retype things. I know Windows 98 only scanned the first 8 characters of your password, and so did Hotmail for a long time. You could just type anything after the first 8 and it would take it. So you sanitize it. One thing you can do is encode things with HTML. This is actually URL encoding, not HTML encoding, %20. HTML encoding would be ampersand NBSP semicolon. But anyway, you can encode a special character as a safe encoding, which shouldn't have the effect. Anyway, boundary validation is what's recommended. So safe data handling is where you write better data that actually will not be fooled by malicious input. Parameterized queries are the solution for SQL injection. They've been known for a long time. If you write queries this way, there is no input that will be misunderstood as a query. The input goes into a data object. The data object is compared to the data in the database. There is no way for the data object to be misunderstood as a code object. So nothing you put in the name can be interpreted as a command, which is fine, but a lot of people just don't write it. But this would, of course, be the best solution. Actually write better code that is not vulnerable to funny characters, and then it doesn't really matter whether you filter them out or not. But that requires retraining your programming staff, and that is difficult or impossible. You know, they've got their traditions, and how much money are you really willing to waste freezing your programming staff? Microsoft did this. Microsoft got so fed up, they were developing Vista to replace XP, and they stopped all development on Vista, and they made all their programming staff read a book called Writing Secure Code and retrained them all and made them rewrite XP. And then they gave the whole thing away for free as Windows XP Service Pack 2. So they sort of wrote off 2 years of profits to change their security posture, which paid off in the long run, but very few companies are willing to make that kind of investment until they really are backed into a corner, and Microsoft was, of course, backed into a corner. People were so fed up with the viruses, they were actually abandoning the internet, getting rid of their computers. It was getting impossible to do anything because the machines were so vulnerable, and they decided to make that drastic step. So you can do semantic checks, where you, this is where you don't just look for particular bad characters, you check to make sure that it makes sense in context. So not just that the account number contains only numbers, but that the account number actually matches the right account number for the person you're claiming to be. That would be a semantic check. Making sure it really is reasonable in context. That would be the safest thing to do if you can do it. So like I say, input validation is risky. Typically you want to say data coming from user is bad. On the server side, you want to say it's good. People like to filter it one step on the way in and then trust it once it's in there. And of course you can't do that because your server has multiple modules. They have different vulnerabilities. and there are different ways to feed data into those different modules. So it's not, this is very much like the recommendation that Microsoft made for networks until 2002. The official recommendation of Microsoft until 2002 was you should have one firewall at the edge of your network to block the attacks, and then inside your network no more defenses, because that's the trusted safe area. And this they abandoned in 2002, and they said, well, it's not really true anymore. People are bringing in laptops, USB sticks, phones, and you really need to have defenses, layers of defenses inside your network, and the same thing's true of your web app. So the right thing to do is boundary validation. You have to find the boundaries where data moves from one module to another, and every time that happens, you have to think about what malicious effect that data could have. This is tough. This means all your developers programming their different databases and languages and everything have to be aware of what's risky and watch for it. So each component getting input from some other component, even on your own network, should consider that that might be malicious. And then you have to do validation checks to check all the inputs that come from elsewhere, not assume that it's a trusted network. That is basically what the latest research that Civiso is putting out, is showing many companies trust input that comes from the local host. And he is able to take input from the web and redirect it so it appears to come from the local host, and suddenly he can do terrible things because the developers assumed that the signal from the local host was trusted. It is understandable why they assumed that, just like most companies didn't encrypt their own local web traffic until the Snowden documents came out proving that they were reading everyone's Yahoo mail by putting a malicious device inside Yahoo's LAN. And they were not encrypting data in the LAN because that was a trusted network. So nowadays, many people encrypt their local traffic. They've accepted the fact that there really are owned machines on your LAN, and you can never get that number to zero and be sure it will stay at zero, so you have to assume in your threat model that some of my own machines are compromised. So here you have people logging in from the input with, they're going to log in, then they're going to see their account details, so you have data coming in from the user into the application server, then the application server has to send SQL data to the SQL database to get it, and then it has to send messages down to this machine to get more information about the account, and all those messages should be checked for risky things, not just the ones that came from the user. Here's SOAP. SOAP is Simple Object Access Protocol. It lets you ask for things over the internet, so you send a request and you get a response that will tell you what you've got here. Send back some information like the name of the company is Microsoft. And you use this a lot for mobile devices and for agile apps. I don't know if agile is the right term, apps that respond well, like what they called AJAX, where you ask for a little bit of data from the server, not a whole web page, but a little bit of data. Here's boundary validation. Like I said, the app gets the login. It limits things like length and bad characters. Then it performs a SQL query. And the SQL step, even though it came from your own server, should be blocking out dangerous characters. The login succeeds, so it goes to a SOAP service to look up like your profile and your account number and balance and stuff. And again, you have to check for this because that's using XML over SOAP, and that has a different series of dangerous characters. And then you send the data back to the user, and when you do, you HTML encode it. This is called output sanitization, and this is also very important to block cross-site scripting. If in case a user puts script on like a Facebook wall and then somebody else looks at it, if you output encode it, the less than and greater than signs are encoded as &LT semicolon and &GT semicolon, so it will appear to the other users as just literal less than and greater than signs. It will not take the effect of script tags. That's highly recommended, output encoding as well as input encoding. That whatever comes out of your app has dangerous things removed from it so it does not hurt the viewer. So here's another one. If you filter to block out script tags, the user could just put in this, and then you'll filter out this one and have one left over. So, you know, you can't do simple filtering and have it work very well. It's very easy to defeat simple filters. If the app removes .. because that's how you move up a directory, do directory traversal, if it does this first and then removes that, then I send this, and it will not find a .. when it looks for it here, because that's not there. It'll remove the dot, won't find a .. because the backslash is in the way. It'll just remove the .. and leave me with the .. So, you know, this is why it's trickier than you think to filter out strings of characters. Then there's canonicalization. This reduces things to their URL encoded form. So there is you can express any ASCII character with % and then 2 digits for the number of the character. So this is hexadecimal. So % is 0.25, So if you want to block apostrophes, you remove %27, but the problem, this happened to, I think, IIS version 4, Microsoft's web server, it decoded twice. So you could doubly encode it. So this string, %2527, the %25 would be decoded and turn into a percent, and that made it %27. So you could sneak an apostrophe up and do SQL injection even past this, which was supposed to prevent it. Another thing you have to do is handle errors. When you have errors, people typically, by default, almost every product gives out too much information for the error message. It tells you what line you're on, here's the page of code, what product I'm using, what version I'm using, and you want to fix that. Also, your logs often log too much information, and they are often visible to the public. There are some entities, Chrysler had that open. There was a thing called LMA that is used on Windows networks that lets you see the errors, and I saw Troy Hunt posted about 5 years ago on Twitter. You could just go to a Chrysler page or Toyota, and you could put an apostrophe in the URL, and it would log the bad request, including the authentication cookie, in the publicly visible log. So you could just send someone a link, like on Twitter, and if they click it and they're logged into their Chrysler account, their authentication cookie will just appear in the publicly visible log. This happens a lot because it's part of the whole cloud thing. They want the logs to be visible to their developers. The developers are all over the place, so they put it in a cloud. They say, well, the logs aren't really secret. But it turns out the logs really are secret. Very often you have inappropriate error messages. Here's one of the many ones that just tells you unexpected end of SQL command, just much information about what crashed. I went to the Republican National Committee's website to check for vulnerabilities a few years ago, and I put like an apostrophe in the URL, and the whole page turned into a giant red ASP.NET code, just page after page of it. And I said, I think I'll quit messing around here. These guys will get mad at me, and this thing is obviously complete crap. I'm sure it's vulnerable, but I'm also sure that talking to them will not lead to anything good. I just closed it and went on with other things. So you got audit logs, recording what happens here, change of failure, credit card payments, access attempts that are blocked, and so on. These are all fine. Logging full client requests is the best for debugging, but you certainly don't want that to go outside your company because the full client request includes their authentication cookie and their password and everything. So the logs should have enough information to help you. You need to have the time to synchronize them with other events and IP address, and you have to keep them private. Attackers will typically try to erase them or read them, so you have to protect them. The wisest thing to do is to store logs on a write-only medium. You have a network where you can write to it, but you cannot, there's no command that will erase it, like store it on a burnable CD or something. Is one way to do it. You have alerts. When really bad things happen, it will send a text message or a phone call to the administrator to alert them. And this is what your IDS does, essentially. Looking for business anomalies, like a large amount of money moving around, or other anomalies that are detected by your IDS as known attacks. You have normal firewalls that block overall network protocol attacks like SYN floods, and there are web app firewalls that look for web attacks like SQL injection. They are not very good at detecting subtle attacks, but they do stop simple attacks like one generated from automated attack tools like Havij. That's what they're for. So there's some value in these things, but you certainly don't remove all attacks. It is fairly simple for an intelligent attacker to sneak past a web app firewall. So when you find, attackers will send in a lot of similar requests hunting for defenses like vulnerability scanners do, thousands of slightly different inputs with different punctuation marks, and your automated defenses can pick that up and terminate their session. Like if someone makes 10 failed logins or 10 screwy looking inputs, just kick them off for a while. That's what Bro does. Bro is what they use at LBL in Berkeley, and they say they don't use any firewall, all they use is Bro. And anybody that sends us an attack, we block that IP address for half an hour, and that turns out to be very effective. So your application has a management interface someplace. You remember there's a whole bunch of these. There's PHP MyAdmin, and I was amazed to find out the US military uses .NET Nuke. Is their main one. When I was doing an authorized pen test of the US military, they had 2 bug bounty programs. I was in one of them. I didn't find anything, but I learned a lot about .NET Nuke to analyze it. That's what they were using in the Army. And so anyway, you have an admin panel, and in here, this is where your web developer spends most of their time. They don't really know a whole lot of detailed code. They live inside some graphic environment, like WordPress has a nice panel to control your thing, and cPanel is another. And those things, of course, are wide open doors if someone can get into them. They often have default passwords, insecure protocols, unsafe extensions, and so on. So the administration panel is often a good place to attack, and it's often vulnerable to the same kind of flaws that routers are, like cross-site scripting and insecure direct object access and so on. So I got a few cahoots about that, and we'll be able to make some progress on Chapter 3 here. So what happens when you log in? Okay, that's authentication, good. All right, how does the website remember who you are? All right, session management, good. All right, what does client-side JavaScript often do? It often does the input validation, which is not a bad thing as long as you understand that you can't trust it. The purpose of that is to avoid wasting your server time with a bunch of badly spelled junk and to quickly respond to the viewer if they're making huge mistakes like not putting the right number of digits in their zip code. But you have to remember you have to revalidate it on a server after validating on a client because you cannot trust that that process really happened. All right, so what process requires writing code that can't be fooled? All right, that's safe data handling. This is, of course, your strongest defense, but it might be impractical to achieve it. And you might settle for something that you can afford, like a web app firewall, rather than retraining all your developers to write different code. All right, so which process removes malicious portions of input and then uses what's left? All right, and that's sanitization, and that's what was going on in those examples where you feed in a script tag by putting half of a script tag in the middle, and the rest of a script tag. If you weren't sanitizing, you would just detect the first one and then throw it back. This is no good, try again. They were removing one and then using what's left, and that's what made it have that effect. So here's winners. Here you learn the basic protocols and languages you need for the web. There's really quite a few of them, and some of them are new to me. You know, when I first went through this book. The web is pretty complicated. I know web developers that have so many certificates for knowing languages, they shrunk them down to 3.5 and put them in a Rolodex. They're like 30 languages. It's nuts. When I started in the 70s, there was a language called BASIC, and a language called COBOL, a language called Fortran, and we would say, which language is going to win? One of these will become the best computer language, and all the others will go away, and that is not what happened. There's just dozens and dozens of languages, more every day. Now there's R and Go, and it seems to be the real thing is to make a specialized language for every purpose. And the web is just a giant amalgam of all these different technologies stuck together. No wonder it's incredibly vulnerable. It's not even all written in the same language, not even close. So anyway, HTTP is the protocol designed that turned into the internet. This is a way to quickly send requests to a server and get data. So you send an HTTP request, you get an HTTP response, and that's it. The server does not have to remember anything. It's done with you. It can go on and serve the next person. That is to make it efficient, like a router. A router gets your packet, reads the address, sends it on, and it doesn't have to remember anything about this after that. It can just go on to the next one, and that's the way to make things fast, especially in the early days when the machines were slow and had limited memory, and they really couldn't be bothered with unnecessary complexity. So your HTTP request looks like this. You send a GET, then you have a URL specifying what you want to see, and then you have a protocol at the end, HTTP 1.1 typically. HTTP 1.1 requires you to specify the host because you might have multiple websites on the same server, on the same port, and the host name tells it which one you want to see, and the rest of this is all optional. You really don't need it. But you often put in a referrer, which tells it where you came from, and a user agent which tells it what browser you're using in case it's going to serve up a different version of the website to a different browser, which used to be just a theoretical issue, and now it is not theoretical at all because people are using iPhones. And most companies do have a different version of the page to put on your iPhone because the normal version would not be readable. And so they watch to see what kind of device you're using, and there are a lot of other headers. So the verb is get or post most commonly. That's the first thing. Here's the URL. This is the part after the question. Here is the query string. This is one place you can put parameters. You can put parameters all over the place, but the most simple place to put parameters is right here after a question mark. This is the name of a file or a folder. This is parameter in name equals value. Name, and then I think question mark name equals value, ampersand name equals value, ampersand name equals value. You can put them here as much as you want. And those parameters will show right up in the URL. and they will be saved in bookmarks, and they will appear in server logs. So putting parameters here is considered a pretty unsecure place to put them, so it is not good practice to put things like a password up here. It'd be a lot better to put that somewhere else, like down in the body of a post or in a cookie or something, where it won't be quite as blatantly displayed to all kinds of people as it goes by. So the referrer, spelled wrong by the way, that's the way it is, that's the official name, is the URL it came from. This means that every website knows where you came from. Now the original idea is you can tell which of your ads are working, but it does mean here are fun things. If you have a popular site like Facebook, you can tell what else is popular. What were people doing before they came here? And another thing that's fun, which Zuckerberg admitted publicly he was doing, if you have a popular site like Facebook, people will log in, they will frequently make a mistake. So if you make a mistake on your password, you'll try your other password and your other password. Most people have like 3 or 4 passwords, and if it doesn't work, they say, oh, it must be my other password. So if you just record the failed password attempts, you know everybody, all their passwords. And he admitted that he used this technique to read journalists' emails to find out what they were saying about Facebook publicly, and was not prosecuted for it. But this is actually a devastating attack, and I'm not aware of any defense. The only defense against this is to really use a password manager, which I'm now finally doing, where I really have a different password at every site, and I don't know any of them. So I don't have this game of, it's my other password. I quit doing that. But most people do, and that means everyone you deal with really has all your passwords, because you try your other password, and that's going to their server, and they could be logging it. If they're Facebook, they are logging it, anyway, or at least they were. All right. Anyway,
LastPass or which one?
What's that?
Which one do you use? LastPass?
Yeah, I use LastPass,
yeah.
which did get hacked. I don't know if it's any better than the others, but they fixed their stuff. But I would use one anyway, even with the risk of they might have a flaw. It's a whole lot better than my old system of trying to remember these passwords, especially since so often it's been a year since I used it. And I really am glad I've got it somewhere I can find it now. Before I had like a Word document somewhere and a text document somewhere, and it was on my other machine, and then I would encrypt it, and then I would forget that password, and I'm like, oh, I hate my life, you know. And there've been studies showing the average person is nuts, especially the average server administrator has like 19 passwords they have to remember. This got Obama so mad, he actually announced that the US government was going to take over passwords and we would all log in through the government. This is like a lot of things Obama said. He officially announced it, and then everyone said, are you completely insane? And he had to pretend like the next day that he hadn't said that. Like, you're going to trust the government with your passwords? This is going to make things better? You're the only one on earth that believes that. Which, anyway, so here's a cookie will appear down here, and your cookie has a bunch of stuff in it. Parameter equals value, parameter equals value. Proper cookies at professional websites are just long random numbers like this because it means something to the server, but it shouldn't mean something to anybody that steals it. If you read the New York Times limits you to 10 free articles per month. And every single time you connect to the New York Times, it sends the headlines in plain text of all the articles you've read this month over HTTP over the LAN. So you can sit in a coffee house and find out which New York Times articles everybody around you has been reading, which I found that and I thought, well, from experience, I know they won't care if I tell them, but in my opinion, that is rude. It's, however, not illegal, and in the scale of security problems, I'm sure they don't care, but I wouldn't do it that way. It'd be a whole lot more professional to have some kind of code number that only they understand, instead of having the readable headlines of everything people have been reading. On the other hand, how many things in the New York Times are terribly embarrassing to read? Anyway, I don't know. Here's the response. You send that bunch of text to the server, and you get a response. The first thing you get is a code number, which is the bottom line, which is, did it work or not? 200 is okay. That's what you mostly get when things work. You asked for something, it was able to find that and give it to you. Then it has a header that tells you some information about the server, which, by the way, you should remove from your servers. This is of no importance to good users, and it just helps bad guys. Your server also, by default, it identifies what it is and what version it is, and you don't really need to be telling that to the whole world. And then you have information here. So there's a header, there's 2 carriage returns, and then there's a body of data coming down, which is like image or JavaScript or a web page or something. That's what happens there. So here's the server's, the banner of the server software. They often tell you exactly what version of Apache they're running and even what operating system they're on, which is an unwise practice, and find out how many of them are running out-of-date Apaches that were vulnerable. And it was quite a few of them, you know, like 10%, and I told them, but they don't care, of course. But anyway, it's... All right, this is where you set cookies. So when you connect to a server, the server will typically put a cookie on your machine so it can track ads, and if you log in, so it can remember who you are. So here it is, setting cookies. Here's what set cookie looks like. You set cookie, then it has the contents of the cookie in name value pairs. It can have as many, it has an expire on a date, which is how long your browser is supposed to keep the cookie before deleting it. And it has the max age and a path, which specifies what parts of the website this cookie will apply to. And all future requests to this server matching this path will include that cookie. So it will remember who you are. And that's why advertising agencies use it to track what you're doing. They put an image on every website on the internet, and then like Google does essentially, and then every website you make a request to Google, and that request automatically has the cookie that Google put on your machine before, so they know who you are and what you're doing. DoubleClick invented this technology, and Google bought them, and this is what the CEO that just stepped down from Google said. He described it as, we go right up to the edge of the creepy line. We make money the more we invade your privacy, but we stop right before it would be creepy. And this is how they know everything you're doing all the time, because they make it economically desirable for everybody to put the Google code on their page. Anyway, and pretty much everybody does. You'll have a pragma. If you have that, it'll tell the browser not to store the response in its cache. Otherwise, when you go back to the same page and it has not expired yet, it will not cache the server at all. It will just show you the stored copy of the page to make your internet experience faster. And that's what the expires headline does. It'll tell you how long to keep this copy of the page before bothering to ask if there's been an update. And there's message body after the header down here, and that contains code for your browser, JavaScript or HTML or something like that. And it comes in different forms, and you'll have a content type here telling you what it is. So this one is sending JavaScript, and that's what this stuff is, jQuery. You can have different kinds of content. So get retrieves resources. You can send parameters in the query string. If you make a bookmark, it will bookmark the entire URL, including the query string. And it appears in server logs, like I said, and on the browser screen, so it's not considered a good idea to put sensitive information in the query string of the URL. Post is the method to send things up, data up typically. You don't want to just put it in the query string. You can put it in the query string of a post, but you can also put it in the body of the message after the 2 carriage returns. And it's not necessarily encrypted, but at least it's not right in the URL to be stored in a bookmark. Now, if you want it encrypted, you should send it over HTTPS, and then whether you send it with GET or POST, it's encrypted in transit. So that's POST. Now, this means if you were to you can click back in your browser and go back to a post page or refresh a post page, it would send another request with a parameter. And the thing they're worried about here is you might have just bought something. And if you refresh that page, you're going to buy another one. So your browser will warn you, if you have a post and you try to back or refresh, it'll say, are you really sure you want to repeat this request including the data? Because you very well might not want to. It's not like refreshing another page. All right, so head is another less commonly used method. Head does not fetch any resource from the server. All it gets is the header. The only point of it is to see if the server is up, check what version it is, see if the clock is right, that sort of thing. Options will show you what methods are allowed. Almost everybody allows get and post, and they might allow options, and they probably don't allow much else. There's really a lot of verbs available, including put, the puts data on the server, which cell phones use sometimes to send parameters up, but normally you don't allow too many of these. So this thing is the Uniform Resource Locator. This is the base of the internet. You have a protocol, a : / then the name of a server, then you can have a : port if you're not using the default port of 80 or 443. Then you have a path and a file name to specify the resource you're referring to on the server. And then you have an optional question, and then param equals value and param equals value to put as many parameters as you want up there. And that whole thing is called a Uniform Resource Locator. And it is a way to uniquely identify every object on the internet. So if you don't specify the protocol, it assumes HTTP. If you don't specify the port, it assumes the default of 80 for HTTP or 443 for HTTPS. There are a bunch of other protocol handlers like Telnet and Mail2 and FTP, and there are a bunch of obscure ones like Gopher that are left over from decades ago and never used anymore, and now they represent security holes. You can trick your browser into doing unexpected things with them. There was a hack of Android phones that was pretty powerful, and also the Skype app on Android and Apple, where you could have a request that would dial a number without asking you first, because you just put a link to like a tel number or a Skype protocol. Anyway, for some reason, people even the internet is not confusing enough, so they have multiple ways of doing the same thing. So instead of having like an app and you have question make equals Ford, model equals Pinto, you can choose to put the make and the model in the URL /Ford/Pinto, so it looks like a folder name, but it's not a folder name. I don't know why you would do this, but people really do it and they call it RESTful, representational state transfer, where the things that look like folder names, some of them are actually parameter values, just in case you were understanding anything. So let's try some cahoots about that. So what portion is get? All right, that's the verb. That's what they call it. This, by the way, is something I've seen Vivek Ramachandran runs SecurityTube, which is really nice, and he talks about verb tampering. It turns out that if you use Apache configuration to limit what you can do, a lot of people accidentally only restrict the get method, but not the post and the options method, so you can do things like get past password requirements by using an unexpected verb. So that's another fun thing to know. Anyway. All right, so what HTTP method would require user confirmation when you click back? All right, that's a post. A post typically does something which, when repeated, might have another effect, whereas a get typically does not. It's harmless to repeat a get, but it's not that harmless to repeat a post. All right, what parameters are stored in the bookmarks? Okay, that's the query string, the part after the question mark in the URL. And which of these is RESTful? Okay, it's that one where you take values and put them in the URL like they were folder names, but they're really parameters. All right, I think we should carry on. So I think we do another section or two of this. We may not finish the whole chapter, but we'll put a good dent in it. All right, so headers. There are a bunch of lines you can put in the header. Connection tells it whether it should close the connection. If you do the 124 class, we do Violent Python, where you write your own Python script to make your own browser, and then you try breaking into websites, and you will find out that most of them allow the connection to persist, so you can make one TCP connection and make 100 HTTP requests without having to make a new connection. And this tells it whether it should end the TCP connection after the one request or leave it open for further requests. Typically you want to leave it open because loading a modern web page takes like 20 or 30 requests to the same server. I got to have the HTML, I got to have the CSS, I got to have the JavaScript, I got to have the images, and on it goes. Content encoding specifies what kind of encoding is allowed. You often allow gzip, which means to save bandwidth and time, it can zip the stuff on the server and your browser will have to unzip it, which is fine for your browser. When you're writing your own tools, you often want to turn that off so you can read the response. But anyway, content length specifies the length of the body, so you know how long it should be. Content type is the type of content, like text, HTML. And transfer encoding gives more information about how it's encoded. There's a thing called chunked encoding we'll look at later, which is very strange looking, and I don't know why people use it, but it is an option. Your request, you can have accept, which tells it what you're willing to accept, like image formats and stuff, accept encoding. Here's your cookie, of course. This is you sending cookies that were set previously up to the servers so it can, I am someone you have talked to before. Here's what you put here last time so you can remember who I am. The host specifies the host name, and it's the only one out of this whole mess that is required by HTTP 1.1. Then there's something about if modified since a certain time, and if none match, and so on. Origin and refer we've talked about, and user agent. Refer is the page you came from, and the user agent is the type of browser you're using. And the response has a bunch of headers. There's an access control header here, which has to do with cross-origin requests, whether one object in one domain can request an object in another domain. We'll talk more about that later for things like AJAX. And other things here, you can specify another tag called an e-tag, like a cookie, to mark you when this thing should expire, and some other ones that aren't used that commonly. Here's set cookie. That one's important. We talked about that one. And there's parameters you can use with set cookie to specify different kinds of cookies, the most important one being the secure flag. You can set a secure cookie, and then your browser will not transmit it anymore over HTTP. It will always transmit the cookie over HTTPS, even if the rest of the page is loading over HTTP. And that's pretty important because if people steal your cookie, they can usually totally get in your account, and there is nothing you can do at all about it. even logging out and changing your password typically does not invalidate the cookie. So here, cookies are how you are identified, and they're automatically sent with every request, so they're flying over the network all the time. And anybody that can read your network traffic, if it's not encrypted, can steal it. So set cookie sets it. You might have something like tracking equals just a long random number. That's a good cookie. Some sites are so foolish as to actually put things like credit card numbers and passwords in cookies, but they're transmitted without any particular encryption if you're not using HTTPS, so you really should not put anything readable and personal in a cookie. It should be a random number that means nothing except to your server. And so if the server sends you a set cookie, then every time your browser goes to that domain, it will add this cookie to the header of every request so the server can know who you are. Until you clear the cookies. You can go manually and clear the cookies from your browser, or unless you go to like an anonymous tab, you can do Shift-Control-N and open an anonymous tab that won't use the cookies, or the cookie will also expire after a certain amount of time. So in the set cookie header line, you can put parameters. Here's the expires that tells you when it will expire, otherwise it will be retained only for the session. Here specifies the domain it's good for, and that's what's called the same origin policy. There is a little game in the world of security which happens over and over again. Someone invents a new technology. They want to sell it, so they tell everybody, this is for your security, this will make you safe. Then it invariably gets hacked. Then they say, oh, that was never supposed to be a security parameter anyway. I found a major medical provider's password on the internet, encoded in a certain file they're using, and I contacted them, and after about a couple of weeks reaching the right person, they said, oh, that password was not a security boundary. And I'm like, what is a password? Anyway, so the same origin policy is the main security feature of your browser, and it means that your browser, if you go to google.com, your browser will send it all your google.com cookies. The problem is, how does your browser know where you are? All it does is look up in the URL bar. There turn out to be about 50 ways to fool your browser about where it thinks it is. You can put something in a frame, you can put funny characters in there, there's a lot of ways to trick your browser where you're not really at google.com, but it thinks it is, and then it will send the google.com cookies. This is called the same origin policy. It's at the heart of all browser security, and there are an endless chain of same origin policy exploits that defeat this. So that's why, another reason why the web is really quite dangerous. Your browser really can't do anything much better than this, but this is a very thin security boundary, the same origin policy. So you can specify the path for which the cookie is valid. You saw it in those examples before. One cookie was valid for slash, and one was just for slash games or something. You can tell it whether to send it securely, and you can specify that the cookie will only be sent by HTTP, which will stop you from stealing the cookie with JavaScript, cross-site scripting attacks, which we'll be doing, which is a popular way to steal cookies. So setting both of these will stop quite a few of the attacks here, involving tricking your browser into sending the cookie to the wrong person, but not all of them by any means. So your status comes back. It's a 3-digit number. They're grouped. 1 is informational, 2 means it worked, 3 means you have to try another request, but they're telling you where to go. 4 means there was an error. The request was could not be understood, could not be processed, or looked for something that wasn't there. And 5 means the server encountered a crash in their code as a result of this request. A well-written application should never give you a 5, but they do sometimes. This means it tried to process your input as numbers, but it was letters, or something like that happened. The most common is 200 OK. That means you asked for something, it was where it should be. 301 is moved permanently. 302 redirects you temporarily. Unfortunately, it is extremely common that people readjust their website and move things, and they just put 301 or 302 redirects on the server and leave them there for years. Because normally it doesn't matter. People go to the old page, it redirects to the new site, who cares? The problem is, everyone upgraded to HTTPS because of Snowden's revelations quickly. So many websites used to be HTTP and are now HTTPS. And they want to remain open to HTTP because they believe, rightly or wrongly, that a bunch of people have bookmarked the HTTP page. So you can go over HTTP and you will get a 302 redirect to HTTPS. This is the kiss of death. Because you passed through an unsafe connection to a safe connection, you can just hijack the unsafe connection and not go to HTTPS. They might as well not be using HTTPS at all as do this, but almost every site does it. Salesforce does it. It's amazing how many people do it. Big companies do this. They just like people think it's okay to run important code on the client because they don't understand it. They also think it's okay to make important redirections this way, and it's not. But people do it all the time. So 400 is bad request, 401 is unauthorized. You have to include some authorization. 403 is forbidden, 404 is not found. And then you have internal server errors, 500, which means something, typically your PHP or some other script code crashed on the server. As a result, it couldn't handle the input. And people have all kinds of custom ones they've made. Here's 100, continue, no content. Anyway, there's a whole bunch of people that have fun with these codes. All right. So that's HTTP. Now, HTTPS is exactly the same protocol over a different transport protocol. SSL is, I think, a layer 5 protocol. So you have the same logic. You have the same structure of the request, same structure of the response, the same status codes, but it passes through a layer of encryption below the layer of HTTP. So originally, HTTPS was running over SSL. SSL is a very old encryption protocol designed by Netscape, and it turned out to be very unsafe. It was cool at the start, but its keys are too short and had many other errors, so they upgraded to SSL2, and SSL2 is still broken. There's no version of SSL that is considered safe at all anymore. Everyone upgraded to TLS 1.0, 1.1, 1.2, and now 1.3. And so everyone's really using TLS, but it is traditional to call it SSL. That became the standard slang term for it. But it's not SSL, and it hasn't been for about 10 years. There are a large number of servers that are running old server software, and they actually allow you to downgrade the connection to SSL. And if you do, it's unsafe. And they will not, browsers are beginning to refuse to connect to sites like that. Anyway, one important thing about HTTPS, the encryption is very good. It protects data in motion, but it does not protect the data at rest. So something like SQL injection that steals the data off the server is not prevented by HTTPS. You send your encrypted request to the server, which is decrypted, processed, and then it encrypts the data and sends it to you. It's not the fix for everything. The only thing it blocks is people sitting next to you in the coffee house sniffing the radio and getting your stuff because they don't have the key. But it doesn't prevent all these attacks. Another thing a lot of people do is use proxies. You'll be using proxies a lot in the project to manipulate traffic to hack into web servers. A lot of people use them at various ends. A lot of companies use proxies because it's the best way to block sites you don't want. Like if you don't want your people playing games or going to Facebook because you're a high school or something, what a lot of people do is just block the DNS resolution for Facebook. Well, it takes high school students about 1 hour to figure out that all they have to do is type in the IP address of Facebook and they get in, so that doesn't stop them. So what's more professional is to have a proxy where there's no direct connection to the internet at all. They have to talk to the proxy server and say, please let me see Facebook, and then the proxy server has to fetch it and give it to them, and the proxy server has a bad list of things it won't fetch. Then they really can't get to Facebook very easily. There's still ways around that. You defeat it with your own proxy. You put up your own server at like samsclass.info that is a page that has a frame with Facebook in it, so that the first proxy thinks you're fetching it from samsclass.info, but samsclass.info is actually serving Facebook inside there, and those things are all over the web, and people also use them to defeat the Great Firewall of China, and so modern antivirus and proxy services and web content management services have humans that keep updating the list of proxy servers and blocking them. And there's a war like the viruses and antivirus of finding all the proxies. So this is the issue of man in the middle. If you're going to go through a proxy that breaks the connection and then goes and fetches things for you, that's called a man-in-the-middle attack. You're not connecting directly to the server. Somebody in the middle is examining and altering your packets. Now, the web was designed to let everybody be in the middle. Your router was in the middle, your gateway's in the middle, your firewall's in the middle, because nobody thought about encryption. HTTPS is intended to not let you do that. You're supposed to be encrypting stuff with a key that nobody has except the person at the other end. So nobody in the middle can intercept and alter that traffic. They don't have the key. That's the point. And HTTPS is very good at this, which means that companies have a huge problem now. This college right here, as I mentioned, their security system blocked my website for hosting malware because I had some projects that had instructions how to deliver attacks. They saw them because people were going to my website over HTTP. So I switched my website to HTTPS, and now the college defenses can't see that anymore. I'm still doing exactly the same forbidden stuff, but it doesn't trigger alerts anymore because they can't see it. That means I can break anything, any of their rules, by just using an encrypted protocol, HTTPS. That's not acceptable, and most companies and military bases and everything else, so they man in the middle HTTPS, and we'll be doing this too. If you do man-in-the-middle HTTPS, you have to make fake HTTPS certificates from the man-in-the-middle, and your browser will warn you that they're fake. So you have to tell your browser to trust them, or you'll constantly be irritated with error messages. And then you can examine this encrypted traffic. So that's a big issue. All right, there is a form of HTTPS that goes through proxies where you make a request and then just forward the packets at level of TCP without opening them, which lets you access HTTPS sites through a proxy, but it does have the defect I described that your company can no longer examine the traffic. So it could be malicious, it could be your company secrets leaving, it could be various things. Most companies are not willing to accept that. They really want to see all the traffic and scan all the traffic, and so they do man-in-the-middle all the HTTPS. By the way, law enforcement agencies can man-in-the-middle without a warning appearing in your browser. Governments, nation states can, and they do it by shady means. There is a conference called Suits and Spooks where you meet the spies and the government agencies that do this stuff, and they buy commercial devices that man-in-the-middle HTTPS, and they have a USB port, and they say, feed in trusted certificate here. So somehow they get one. And it's been an open secret in the business. I think about 5 years ago, someone finally admitted it publicly, that all the root certificate authorities like TrustWave and Thought and VeriSign, they all sell root certificates to people for a price. They're not supposed to. The entire trust model of the internet is based on those people not lying about who they are, but for a price, they will let you lie and impersonate them. And I have some other dirt I can't say where I'm being recorded that I've heard about what's going on. There are quite a few really important business functions going on the internet in ways that are illegal because they have to do it that way. And anyway, the whole trust model, just like the trust model you have in any authority figure, is not perfect. There are times when they have to do the thing they pretend they're not doing to get the job done. Anyway, so HTTP authentication is a really old system to identify people, not commonly used directly over the internet, but very common inside companies. Basic authentication was the first one where it would ask for name and password, and you just put it in the request in base64 form, which is just an encoding that uses 6 bits at a time instead of 8. So it scrambles it so you can't read it, but it's very easy to reverse. NTLM is a Windows NTLM protocol, which is MD4 hashing. Digest uses MD5 hashing. All these are considered to be very weak encryption techniques, pretty easy to reverse or break in normal circumstances. So by themselves, they're all considered pretty unsafe protocols, but if you put them over HTTPS, they're fine. Then you put another layer of encryption on top, and HTTPS is real strong encryption. Modern standards, nobody can crack it without the key, unless they use various dirty tricks that we talk about a lot in hacking class. So we're down to the B here. And so the request header tells the server what web page you're coming from. All right, that's the referrer, good. All right, how can the server make sure the cookie will always be sent with encryption? Well, I'm surprised so many got it right. It's in the set cookie header. The secure flag is there. When you set the cookie, you set it as a secure cookie, and from then on your browser is supposed to encrypt it. All right, what status code tells you the page was not found? Okay, that's 404, good, okay. What transport protocol does HTTPS use? All right, it's TLS, good. People are doing quite well. You haven't fallen asleep yet? All right, so web functionality. On the server, in the old days, you'd have static content, just pages and images, but now everything is pretty much customized, like Amazon. If you go to Amazon, you see a totally different page than anybody else. It sees who you are and shows you different offers and such. So there are scripts on the server dynamically generating the page, depending on cookies and your IP address and how it knows who you are. So you're sending parameters up to the server. It could be in the query string, it could be in the file path like REST, it could be in the cookies, it could be down in the body after the 2 carriage returns, and your server can take any of that data and use it to customize the page. In principle, it could take it from the user agent, and it does, of course, at least to figure out if you're on a cell phone or not. So your server has got scripting languages like PHP, VBScript, and Perl up there. It's got application platforms like ASP and Java. It's got to have a web server of some kind, which is the main service that listens for the HTTP requests and puts out HTTP responses. That's typically Apache or IIS. I think IIS is now the most popular one. It used to be Apache. But if you're a Microsoft shop, you have to use Microsoft everything for it to work best, and you use IIS. If you're an open source shop, you typically use Apache, although Nginx is coming up. Nginx was a stripped down version of Apache, originally designed by Russian criminals to run botnets because Apache wasn't fast enough. So they stripped out all the unimportant parts of Apache and made it really fast. So high performance servers typically run on Nginx these days. You got databases up there with important information in them like passwords and credit card numbers and customer addresses. And you got a lot of other things out there, file systems, SOAP services, and all sorts of things taking requests from your smartphone app and all the parts of your web page and serving bits of data to all your customers. Java is huge, really important. Java is very painful to set up, very slow, very clunky, very buggy, and yet everybody puts up with it because it means your code is platform independent. So you don't have to write another version of your app for another platform. And also, it is designed for enterprises, so it will scale out to a huge cluster of servers. So it's very clunky to set up one server in Java, but once you get it working, you can easily spread out to 1,000 servers. And so it's very important to learn, and if you do the CCDC contest, you're always handling Java-based servers there. You have to kind of get used to them. I do the Wall of Sheep at DEF CON, and that's all running on Tomcat, and that's a Java platform, and I've gotten used to it. It's good to get, if you do anything touching enterprise level stuff, you will have to learn how to handle Java. It's what everybody's using, and it is not fun. It's painful. Well, I had a Java-based thing I used in my 123 class. It was just a game for students to play. And when I installed it on a cloud server, it took the server 45 minutes to boot up. And I couldn't believe it, and I checked, and this is a known problem. Tomcat needs a lot of entropy, and there's not enough entropy. So it waits to build. You have to install a special entropy generating app, and then it'll boot up in 5 seconds. And I said, you gotta be kidding. That can't be true, but that is true. Anyway, so it runs on every platform, of course. That's the whole point of it. It runs equally badly on every platform. That's why, I mean, there's a knock-knock joke about this they had a while ago. They say, knock, knock, who's there? Java. Anyway, and that's the way it is. Like, I thought my server was broken when it wouldn't boot up. I didn't wait 45 minutes. Then I finally got fed up and went to bed. I got up in the morning, it was up. I said, wait, what happened? And I started Googling, can it really take a long time to boot up? I said, yes, it can. Anyway, so that's the game. There's Enterprise Java Bean is heavyweight software for business logic. There's plain old Java objects called POJOs that people use. There's Java servlets that people use on servers for these. And there's Java web containers. And there are whole classes and everything in it you can take here. And it is a whole important field to do all that Java programming if you want to. It's pretty, and I've done a little bit of it here and there, enough to sort of hate it, but it is important. You have to know about it. It's a real thing out there. All right, and there are often third-party components included, like components for authentication and presentation and database relationships and logging that are added in. All right, then there's ASP, which is Microsoft's, ASP.NET is Microsoft's language for server-side functionality. And this is their .NET framework, which is quite popular at Microsoft-oriented shops. If you're running IIS, you typically run the Microsoft ASP to go with it. And you can write in any of several .NET languages, including C#. And you write in Visual Studio, which you can get for free from the college. Visual Studio, the Enterprise Edition, costs $10,000 for a license. You can get a free copy from the college. You'll use it a little bit in the exploit development class to write some C code and compile it, but it is a huge platform and you can do all sorts of sophisticated coding in there. We're using it for very simple things. I just use it to be the Windows equivalent of GCC, which is, you know, like using a Cadillac to smash a tin can. But anyway, it will do that in addition to 1,000 other things I don't understand. So ASP.NET is another server-side platform, and the open source community typically uses PHP. PHP was originally called Personal Homepage. Then they renamed it to PHP stands for PHP Hypertext Processor, so the P stands for nothing, which is a recursive Linux joke, and they love these jokes, and this is why they can never get a date. This is nerd credit you get by having recursive languages and recursive acronyms. But the PHP is famous for being insecure. It is spectacularly insecure. You can write a very simple PHP app that is safe, but if you have a real app that you actually use on a server for 6 months, the odds are like 90% in practice that there's a way to do uncontrolled file uploads and downloads on it. That's how people get hacked all the time. PHP is fun and easy to write in. Most of my website is on PHP, the part I wrote intending for people to hack into it. So that's what LAMP is. LAMP is the open source Linux, Apache, MySQL, and PHP. That's what people typically use if they want it all to be free. But they typically get hacked through the PHP because it turns out to have a lot of problems, and we'll do a bunch of hacking of PHP sites as we go ahead in this class. You'll see you can write it securely, but that's not usually how it turns out. People have bulletin boards on PHP, and PHP MyAdmin have web control, they have webmail, photo galleries, shopping carts, wikis. There's open source everything out there in PHP. You can just download it and use it, and that is one of the main ways people get hacked, because they download some code that somebody else wrote that they don't understand, and they just use it. My website got hacked that way. One of the first times I was teaching first time I think I taught the advanced hacking class, there were 2 students in the back ignoring my lecture. However, a laptop, mutter, 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 I'm lecturing, mutter, 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 muttering louder, mutter, mutter, mutter. I was just about to yell at them when they jumped up, yes, we just hacked your website. I said, well, they're right on target. They weren't ignoring the class. And so because I wanted to put headlines on my headline. And I found some code that would take /dot headlines and put them on my site, and I just put it in without reading it, and it was vulnerable. Because that's what you do. Like if you have WordPress, you find a plugin, you just add it. Of course, some idiot wrote it. It's not reviewed by anybody. And you add another one, and pretty soon one of them has a horrible hole. So if you use other people's code, that's going to happen to you unless you have some reason to believe that they know what they're doing. I didn't care. Oh, well, how bad could it be? It's just a headline. Well, it could be pretty bad. Ruby on Rails is another big popular one. And in practice, it has some vulnerabilities too, but it's quite popular and fashionable these days. And there's SQL. SQL is used to make requests of a database to see what's out there and update and retrieve data. You have to have a database if you're handling a large amount of data, and SQL is the most common language used for this. And there's nothing intrinsically wrong with SQL, but in practice, people tend to implement it in an unsafe way and have SQL injection, where you send something to a web server which misunderstands it and sends a query to the SQL server which asks for more than you ought to be asking for. But the SQL server is working as intended. It's not that it's broken, it has the capacity to send me all the data if you request that. The web server should not have let me ask that, but it often does. So this is the most important vulnerability in the world. More than 90% of all stolen data has been stolen with this one problem. If you only know one thing about security, it should be SQL injection. It is the most important security problem in the world. And we'll play with it in this class, you'll see it. XML is just a way to encode data and stick it on the network. This is how Microsoft Office works now. It's how it stores everything. Everything is plain text, and you have an opening tag and a closing tag. So pet and /pet contains the object named pet, and the value is Ginger. Then you have pets that includes a dog and a cat, and that's all. It's just a way to format data to store it on a drive or send it over the network. Nothing very special about it, but it does mean that if you have network-connected XML requests, if you can inject extra less than signs or greater than signs, you can break the matching and accomplish the same thing as SQL injection. I did this to a college a few years ago. I found XML injection into the library code. I think those guys actually cared when I told them. Most of them don't. Anyway, then there's SOAP, Simple Object Access Protocol, lets you send requests to the server that are standard HTML requests and HTTP requests, and then it sends back the data in XML format. This is used by a lot of services, including mobile phones, apps. So SOAP response will look like this, HTTP 200 OK, and down here it will have the quotation in XML format. So you send it a request in XML format, and it sends you a response in XML format. And this is the way modern websites and modern apps work. You don't just reload the whole page. You want one thing to put here. It asks for this one thing and puts the one thing there. That way it's faster and uses less bandwidth and everything, and looks better for the user. So that's, what?
So Canvas generates its quizzes.
Yes, Canvas is another web app. I'm sure it does this, yeah. It'd be kind of fun to look for the network traffic of Canvas and figure out how it works. So I don't know if you, somebody was telling me that if you go into Canvas, there's a way to view the quizzes before you log in, so you can cheat on the quizzes. If somebody figures that out, it's worth extra credit. That's awesome. That's what we're here for. But if you go into somebody's proprietary system, talk to me before you go public, because in principle you can be breaking the law and getting in trouble. But we're certainly using Canvas, and finding a defect in Canvas, I would say, is fair trial. But only do it to my classes. If you do it to some other teacher, then they might not be having the right attitude about it. But anyway, that's awesome. If you find a hole in Canvas, you could like give a talk and write a paper and improve your career. Educational software is usually horrible, very vulnerable. All our stuff here was running on plain text protocols, all our important stuff. All the education stuff I've seen is very bad because it has a very small market and very small amount of money. So it really is what a big company like Microsoft would call an early pre-beta, is as far as it ever gets. Anyway, SOAP uses this thing called Web Services Description Language, which will tell the SOAP client what services are available. And we'll talk about these things more and more. I've seen this, I think, in Canvas. I see the, we'll get there a little later. I see it passing authentication and security information to the server in this XML-based format, which is notoriously hackable. So I'm pretty sure Canvas is pretty wide open to a lot of the attacks you're going to learn in this class. And if you figure them out, let me know. Anyway, so this is the last Kahoot, and that's as far as we're going to go today. What system uses POJOs? That's plain old Java objects. Okay. What language is used on LAMP servers?
Trick question. Could be either.
Well, it should only be one answer, I think. But this is like who's buried in Grant's tomb.
Yeah.
Okay, and on that list it's PHP. Good. All right. So, what system looks like that? Okay, that's XML. Okay, and what system uses WSDL? That's SOAP. All right. So here are the winners, Patrick, Emmanuel, and Jeff. And I have a new entry, Jeff. And unless your name is really Jeff, you might give me some more information. Is Jeff here? Perhaps Jeff is online. Maybe J. Tom. Oh, Jeff Tom, probably. That's probably it. I think I'll assume that's Jeff Tom. All right. I think it'll do. All right, so I'm going to go to the lab. I know you haven't been here before. After class, I go to Science 214. There's a lab where you can do these projects if you want. Most people prefer to just go home and use their own machines, but I'm here in the lab if you want to ask questions or anything. And in fact, starting about next week, there will be open hours in the lab and even tutors. So if you want to work on campus or get help, the S214 Open Lab Hours is linked right from my homepage. And as you can see, we're getting a pretty good bunch of volunteers to go in there and open the lab and tutor, so these guys could help you with your projects. Anyway, you should start. The lectures and quizzes are good, but you should also be doing the hands-on projects. So go to 129S and click Projects, and here they are, and you should start doing these things. The first one is command injection, I showed you last time, and the second one is SQL injection, and then you start using burp. So I'll probably demonstrate the SQL injection next time, but you should start doing these things. And you have a couple weeks before they're due, but starting early is better. In case you get stuck on something, let me know. And you don't even need a virtual machine or anything for most of these. These being web application hacking class, we really don't need to run the targets. The targets are just my servers. I think you lose your virtual machine in 6, but only a couple of these projects you actually use virtual machines. You just, any kind of normal browser will do for what we're doing here. So give it a shot. I'll see you next week, if not sooner.